Okay, so once you have those opened up, two quick review problems up at the top, factoring out the GCF just like you did on homework last night. So go ahead and do that. Okay, so quick review of factoring out a GCF. I need the biggest number and variable combination that will come out of each of those terms. So what can I divide out of 3, 27, and 9? 3. So my GCF, let me get a different color, is 3. And then what? How many x's can I take out of each of those? Just a single x. So 3x would be my GCF. So I'm dividing each of these pieces by 3x. Remember when I do, and this is super important, guys, because today builds completely 100% off of this. Okay? When I factor out that GCF, it needs to come out in front of my parentheses, and then whatever's left goes inside. So 3x to the third divided by 3x is just x squared. 27 divided by 3 is plus 9. X squared divided by x is x. Negative 9 divided by 3 is negative 3, and the x's cancel. Okay, questions there? Okay, on number 2, looks like the biggest number I can divide out of all of those is 5. Can I take any x's out? No. So just divide every piece by 5. So 5 is out in front of the parentheses. I'm left with x squared plus 4x minus 1. Okay, questions there? All right, so this is super, super, super important. And after today, or maybe at the end of the day, I'm going to start putting a kind of a factoring, quote-unquote, cheat sheet on the side of the front board to kind of give us references of when to use what kind of factoring method. Basically, what it boils down to is how many terms are there. Okay? That's basically what it boils down to. Anytime there are 4 terms, we are going to group. Okay? So we only use grouping when we have 4 terms. So go ahead and fill that in. So we're only going to group when we have 4 terms. What do you do when you group stuff? Just in general. Yeah, so you put it, you take, like if I took this class and I grouped you into groups of 5, I'm taking a big chunk of something and breaking it into smaller pieces, right? So that's essentially what we're going to do today. I like to call grouping a GCF party. Because guess what grouping is? You go GCF, and then you do a GCF, and then guess what you do third? A GCF. Okay? So if you know how to do GCF, grouping is going to be easy. So when do we use grouping?
GCF.
No, when do we use grouping?
When you have multiple terms. When you have
4 terms. Be specific. 4 terms. All right, so we see 4 terms. On example 1, grouping. So I see 4 terms. I group them into chunks of 2. So group the first 2 together and group the last 2 together. Okay, so I'm going to do this problem a little bit differently than we'll do the rest of them, just so we can kind of break it up. Okay, so this is what I want you to do. Okay, so just rewrite x squared plus x down here. Just rewrite the first group. After you've rewritten the first group, please do a GCF. So factor out the GCF of those first 2. I'll give you about 15 seconds. Okay, so what is my GCF of x squared and x? X. So if I bring an x out and divide each of these by x, what am I left with? What's x squared divided by x? X. What's x divided by x? 1. So plus 1. So I have x parentheses x plus 1. That's the first half. Okay? So right beside that, and you may want to use a different color. I'm going to use a different color. Bring down the last half of your original problem. So plus 2x plus 2. And now with that plus 2x plus 2, do another GCF. So go ahead and do a second GCF with your 2x plus 2 part and just put it right down there beside our x parentheses x plus 1. Go ahead. Okay, so what is my GCF here?
2
2. Is it positive 2 or negative 2? Because that's very, very important here. Positive 2. Okay, and the one kind of thing that I will point out to you is since it's positive 2, I have to make sure I get a sign in here. So behind my blue part, I'm going to do plus 2. Since it's positive, do plus 2. Because this is still all one big equation. We're just kind of breaking it up into a GCF and then a GCF. So if I take 2 out of both of these, what's 2x divided by 2? X. And what is 2 divided by 2? So plus 1. So I did a GCF with the blue, a GCF with the red. Now I'm going to do one more GCF. Now, can somebody remind me what am I looking for when I look for a GCF?
The greatest common factor.
Tell me what that is.
The biggest multiple, or no, the biggest number that can be multiplied to get both numbers.
Okay, or we could do it on the flip side and say the biggest number that I can divide out of both of those. So I'm kind of looking for something in common that I can divide out of both of them. Okay? Right now on the board, you should see 2 big terms. You should see a big blue term right here and a big red term right here. What do these 2 terms have in common?
X plus 1.
X plus 1. Does everybody see that? Yep. And your if you do factor by grouping correctly, your parentheses should always be okay, 2 stipulations. If you do factor by grouping correctly, and if it is able to be factored, okay, your parentheses should always be the same. So I'm just going to do a GCF, and I'm going to bring out x plus 1. So if I bring out x plus 1, so I'm going to bring x plus 1 out of both of those terms. If I take x plus 1 out of the first term, what am I left with? So if I take x plus 1 out of this term, I'm left with x. So it's going to go in my second set of parentheses. If I take x plus 1 out of the second term, what am I left with? 2. So plus 2. And there are my 2 sets of binomials. Okay. I've taken something that was complicated, that's this original problem up here, and broken it down into simpler parts. If I set this up here equal to 0, this would not be very easy to solve because I have x squareds. I would have to take the square root, but then I would have the square root of an x, and that wouldn't work either. This is not easy to solve if I set it equal to 0. Is x plus 1 equals 0 easy to solve? X plus 1 equals 0? That's not easy to solve? That's easy to solve. Just minus 1 to both sides.
Oh, yeah.
What about x plus 2 equals 0? Is that easy to solve? Yeah. Okay. So I'm taking something complicated and breaking it down into its simpler parts. Okay. All right, let's try example 2 together. So I'm going to just kind of do this one how I would normally do it, kind of all at the same time, but still breaking it down into my separate GCFs, okay? So I group it into first 2, last 2. All right, so out of my first 2, what does 7ax and bx have in common? X. So x is my GCF. I bring an x out. If I divide it out of both of these pieces, 7ax divided by x is 7a. Negative bx divided by x, the x's cancel, I'm left with minus b. So that's my first half. Stop me if I go too fast, okay? We okay on the first half? Yeah. Okay. Second half, what does 7ay and negative by have in common? Y. Is it positive y or negative y? It's positive y. So I'm going to do plus y. And then bring my y out of both of those. Divide my y out of both of those. So 7ay divided by y is 7a. And negative by divided by y is negative b or minus b. So at this point you have to stop and ask yourself, are my parentheses the same? Are they here?
Oh, wow, they are.
They are. So if they are the same, you're ready to move forward. If they are not the same, you need to go back and check your work because you've either done something wrong or maybe you didn't quite take out the right thing. You didn't take out the right GCF on one of your pieces or something like that. So if your parentheses are not the same, do not keep going. Okay? All right, so they have 7a minus b in common. So 7a minus b, I'm going to bring that out front. Take it out of both of my sets of, or both of my terms, and what am I left with? What am I left with? X plus y. So that's my second set of parentheses, x plus y. Okay? All right. I want you guys to try example 3. Okay, try example 3. Make sure your parentheses are the same. This one's a little harder to make sure your parentheses are the same. So I'm gonna give you some time to work here, and then I'll come in and help. Okay, go ahead. Okay, so I grouped first two, last two. Let me zoom in here a little bit. Okay, so out of my first two, looks like I can divide a 3 out of 3 and 6. And I can take a y out. So my GCF here is 3y. So 3 divided by 3 is 1. Y squared divided by y is y. Negative 6 divided by 3 is minus 2. Y divided by y is gone. Okay, what can I take out of 4 and 8? 4. So plus 4. So negative 4 divided by 4 is negative 1y, and 8 divided by 4 is plus 2. Do your parentheses match?
No.
No. What do you notice about your parentheses? They're opposites, right? Instead of positive y, it's negative y. Instead of negative 2, it's positive 2. How can I remedy that? How do I fix that? What do you think, Isaiah?
That's a negative between the two.
Okay, so if I bring out a negative, that flips all my signs, right? So in order to make my parentheses match, what should I factor out of the last two? Should I factor out 4? What should I factor out?
The negative 4.
Negative 4. So if I factor out, so let me erase here. So get rid of this. Get rid of this. Say now I try a negative 4. So now it's minus 4 in the middle. And I divide each piece by a negative 4. Now let's see if my parentheses match. So what's negative 4y divided by negative 4? Positive y. And what's 8 divided by negative 4? Negative 2. So minus 2. Now do your parentheses match? Yes, you have to be on the lookout for that. In general, when this happens is if there's a minus sign. Oops, I want to erase. Hold on. In general, when it happens if there's a minus sign in the middle of your groupings. Okay? Don't use that as a rule, but in general, if you see that, be aware because it's usually going to happen. Okay? So now my parentheses match. I can bring out the y minus 2. If I bring the y minus 2 out, I'm left with 3y minus 4. Okay, can I get a comfort level where you're at right now, 0 through 3? Okay. Mostly 2s, couple 1s, couple 3s. All right, that's fine. All right, so that being said, let's do a couple independently. So it looks like there's 4 down there. I want you to do... Do 1, 3, and 4. No. Do them all. Do all 4. It won't take you that long. Okay, I'll give you about 4 minutes. I'll post answers. You can ask questions, and then we'll move to homework, okay? Okay, so number 1, out of the first 2, I can bring out a y. I'm left with x plus 2. What can you divide out of x and 2 both? Anything? There technically is something. 1. Okay, so if you look up on my screen up here, you can see that my GCF of the second pair was just plus 1 because there was nothing else I could divide out. Okay, you still need that placeholder there. The parentheses are obviously going to stay the same, but the parentheses match, so I bring out x plus 1. And then I don't just want y back here. That's why I have my placeholder at +1 here, so it's y plus 1. So keep that in mind. If you can't factor anything out, you really can. It's just a 1. So leave it there, okay? Number 2 was one of those where I had to factor out the negative out of the second piece. So you see back here, in order to make my parentheses match, I needed to do a GCF of -2. And then I'm left with 4b minus 5 inside the parentheses. Questions on number 2? Okay. There's 3. 3 was a pretty straightforward one. X out of the first 2, 4 out of the last 2. X plus 3 is left in the parentheses. Questions on 3? Okay, and 4. Out of the first 2, I can bring out an X. Out of the last 2, I can bring out a -3A. Right? In order to make my parentheses match, I need to bring out a negative. Sometimes, guys, too, I resort to, once I do the first grouping, in order to find the GCF, I basically just ask myself, okay, so I see X here. Is everybody looking at my screen real quick? Everybody look up there. I see an X here. I know that I'm going to want an X here, so I just look at this term and I say, okay, what would I have to take out to make my parentheses match and make an X? It's a -3A, right? And then generally the last one matches too. If not, you have one that's not factorable. Okay, any questions? Okay.